and welcome to TFI Tips. Reet, this is a video that I've wanted to do for ages, not meaning to do, but wanted to do for ages. It's advanced iParts, not entirely everything about iParts, but just one particular thing in the advanced area of iParts. It's really useful. It's a really useful tip, which I think a lot of people can get some use out of, regardless of what industry you work in. If you're not sure what iParts are, and you haven't used them yet, check out this video that I'm going to link up here, which is my tutorial on how to create basic iParts. You kind of need to know that before we do this, or this won't really make much sense. Okay, what are we doing here? Right, well, this here that you're looking at on screen is actually a plastic pod. Ooh, look at that. Science, mate. Science. And it's a real-life component. This is a real-life part which I modelled about 10 years ago, actually, for a real customer. And it's called a carrier board. It's designed to house circuit boards. So what happens is the customer will get circuit boards manufactured, right, like bespoke custom circuit boards. And the circuit boards slide into these gaps here, into these grooves. And then the circuit board slides into the carrier board. And then a plastic cover is put on top. So it turns into like a housing for a circuit board. And they buy these carrier boards in set lengths, right? So they might come in like 1 meter strips, and then they'll cut them down to whatever size they need. But those sizes can be anything, right? There's almost an infinite amount of different variations of size that this board could need to be, which poses a problem with iParts. And this sort of applies to any industry, whether it's woodworking or whether it's metalwork, anything really, is that you want to be able to control the size and not have a predefined set lengths to choose from. And that's why iParts aren't really suitable for this in their normal sense, because an iPart table is just a predefined table of values. You'd say variation 1, the length's going to be 100, variation 2, the length's going to be 300, variation 3, blah 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 blah, so on and so forth, yakety and indeed schmackety. So we want to be able to control what the cut length's going to be based on whatever it is we're doing at the time when we place it. And that's what the tip and or trick is going to be here, as well as a few extra things thrown into the mix just to make it a bit more workable. And everything that we're doing here can actually be done manually, but we're bros, right? Yeah, you want to be a bro, you want to be a baller, you want to do it properly, you want to use a bit of automation, you want to be that guy, that's a smart ass, and we're going to do it that way. So let's get cracking. Right, so this part that we've got on screen here, it is just a normal extrusion, right? You could model up the exact same thing just by drawing a circle and extruding it, right? That's all this is. It's a sketch. It's a fancy sketch, granted, but it's a fancy sketch extruded by like 400 mil or something like that to create a length of material. That's all this is right now. It's a normal part. There's no hocus pocus or voodoo gone into this at all. It's just a normal part, and that's where I'm starting from here. So the length of the extrusion, if we edit that feature, the length is just 400 mil, right? It's just a number typed in to get the length. And that's where we're going to start. So we're going to go to the parameters, and what we need to do just to make this is like prep work that we're doing here. So to get the prep work started, we're going to go to the bottom of the parameters box, and we're going to add a custom numeric parameter, right? So this is going to be a parameter which controls the length of the board. So we're going to call this length. Let's just not get cocky. Let's just keep it at length. Right, oh, I don't need to know about volt. And then the length value, this can be anything, right? It can be anything. This is, what we're working on here is the iPart master. It's the iPart template. Call it Queen Bee, right? It's the Queen Bee of the iPart, and it's going to spit out different variations of itself at different lengths. But this is Queen Bee. So whatever the length is in here, it kind of doesn't matter. But if you want to be OCD about it, you can maybe put in like a meter, and then that might be what you buy them in, right? They might be bought in 1 meter length, so you can set the default value to be a meter if you want to. And then what you do is you go to the extrusion and then edit the feature, and then for the length, instead of just having a number in there, you can just type in length, and then that'll change it to be a meter. And just to make sure that works, you can go back into parameters, little FX button on the toolbar at the top, and then if you change the value of length, you should see it update in the background. So that length parameter is now controlling the length of the part. Read. Oh, we need to go back into there. The next thing we need to do is tick this little box here for export, right? That's the export parameter button. You want to do that. And that exposes the parameter later on for it to be used in other areas, which we are going to do. We're going to use that, so we need to. That needs to be a thing. Okay. The next thing we're going to do is convert this to an iPart. We're going to do it now. So we're going to go to Tools at the top, and then we're going to go. No, we're not. We're going to Manage, and we're going to select Create iPart. Right. Creating the iPart is going to be a little bit different from what you would normally do on a basic iPart. On a basic iPart, you'd have multiple different members, right? Multiple different variations. So if there was 5 possible lengths that this board could be, you'd have 5 members or 5 rows in here with the length at 1,000, 1,200, 1,300, whatever the lengths are going to be. But because we're going to have a custom cut length, we're just going to have one member in the iPart table, and we're going to manage that accordingly. So the first column is the member name. This is what the file name of each iPart is going to be that Queen Bee spits out. So when we place this board into an assembly, Inventor is going to say what size do you want it to be, and then it's going to create a physical file of that part at that size at the time you create it. And it needs to have a file name, and it needs to be unique, because you can't have multiple files of the same file name. That just leads to bad times and much sads all around. You just don't want that to happen. So for the member name, we're going to just say, right, assuming the part number, right, and I've made up a part number for this. The part number for this part is TFI-12345. That's the part number. And the part number is quite important here, because you don't want to have a different part number for every board, because it doesn't matter what length it comes in at and what length it's cut at, it's the same part number. It's the same piece. You're buying in that part and then you're just cutting it. Cutting it down doesn't change the part number, obviously. So we're leaving the part number at that. So for the file name, this is up to you, but I'm gonna create the file name based on the part number. Again, it just makes managing it a little bit easier. So for the member name, we're gonna have TFI-12345, and then we're gonna have -0. The reason for that is each time we use this iPart, it's gonna create a new derivative. It's going to create a new file for each cut length in the same folder. So you can't spit out the same file name over and over again. It's going to Windows just adds a 1 on the end of it, or 1, 2, 3, 4, 5. So if we put -0, our multiple files are going to be -01, -02, -03. So we get like an incremental number for all the different. You'll see it happening when I do it. You'll see it happen. But we're just going to leave that as -0 for the file name. The next column is the part number. We're just going to leave that at TFI-12345. Like I said, it is going to be the same part number for every single one that we create. So that's going to be a constant. And then the magic comes in this column. For the length, we're going to right click on the column header, and then we're going to make it a custom parameter column. And then that changes the cell color to blue. The reason it does that is it's just highlighting. It's just like a color chart to say, right, this is a custom parameter column. The user can specify this value whenever they place the iPart into an assembly in the future. So that's that done. And that's all you really need to do in the iPart table. So you click OK, and then that converts the part into an iPart. You've got the table in the table link icon thing in the browser on the left-hand side. If you expand that, you'll see you've got one variation, TFI-12345-0, which is a file name that we said we should have. We're just going to leave it at that. Okay, we're going to click Save. And then the final thing we're going to do before we start, well, there's a couple more things that we're going to do. We're going to go into the properties of the iPart. So we're going to right click on the browser header, and we're going to go to iProperties and go to Project. Right. This again is entirely optional, but like I said, if you want to be a bro, if you want to be a smart ass, and you want to look like you're an absolute genius at this kind of stuff, these are the type of things which just set you above everyone else. For the description, every single variation of this board that gets spat out, it's going to create. You could end up with hundreds of child versions of this Queen Bee iPart, right? They should, in theory, all have the same description, because it is the same thing. It's just cut to a different length. So the description should be universal. So the description of this part is, it is a plastic PCB carrier board. Right, that's it. You can type in where you buy it from if you want, but it's going to be constant throughout all the different variations that we create. But what you might want to do is have some differentiator in each one of the variants for the cut length. If you open up a certain one of these boards, you might want to say, well, what size did I cut this one to? So what you can do, like for example, in the stock number, you can say, right, I want the length of the board to be shown in an iProperty. And I don't want to do it manually. I want it to automatically type in itself what the length of the board is. So for stock number, what you can do is put an expression in by typing in equals, and then type in cut. This bit here is entirely optional, right? Cut to, this is just free text. So cut to length of, and then what you do is open chevrons, and then you type in our custom parameter name, which was length. Right, and then close chevron. So equals cut to a length of length, and then what it'll do is it'll look at the parameter that controls the length of the board, and it'll put that number in between these chevrons. It doesn't show you the chevrons, but it just puts it in there. Click apply, and there you go. Cut to a length of 1000 millimeters. You can change the units if you want to. We'll do that in a second, but that's it, done. So we're going to click close on that, and then we're going to go to tools, then we're going to go to document settings. Now the units, I think, yeah, this is where you would change the value. I think this is where you change the value of the units, right? I might be wrong. But we're going to have 0 decimal place. We're going to go back to properties and project, and then we can just update the parameter. No, it wasn't that value. Oh, I think it's in the parameters area, actually. I think it might be in here. Custom parameter, custom property format, and then take off trailing zeros and leading zeros. Done. And let's see if that's took that off. Boom! There you go. That's where you do it. Right, so you do it in the document settings. Anyway, right, let's go to the last thing that we're going to do before we start using this properly. We're going to go back to document settings, and then we're going to go to bill of materials. Now, the bomb structure, right, I still haven't done a video on a bomb structure. I'm going to do that soon. It doesn't make any difference whatsoever really in Inventor whether you do this or not, but it's just to keep OCD happy. Change the bomb structure to purchase, because in theory you do buy this in, unless you're the company that physically makes these, which you don't. You'll just buy them in, so you just change that to purchase, but it doesn't really matter. And not until you start chucking it into somewhere like Vault Professional or a PLM system, something like that. It doesn't really matter what this is set to. And then this is important. The base quantity at the moment it's set to each, which is fine. Each is fine for things like valves or elbows or widgets and gadgets. You buy 10 valves. You buy 10 each of the valves. We're not doing that. We want to buy a length. So we change the base quantity to the length parameter. So you can choose, I think, either one of these, but we're going to just stick with export parameter, change that to length. And now Inventor's being told that when it quantifies this part in an assembly, calculate the quantity in length in millimeters. And then click OK, and then click save, and that's it, done. That is the iPart prepped, ready to be used in an assembly. So what we're going to do is start a new assembly, and this is just a sort of training course example. It's empty. In the real world, you'll have other parts in here. You'll have to constrain it up to other pieces, and that's fine. That's absolutely fine. It doesn't make any difference whatsoever. But we're going to just place this part, plastic board. So that's the Queen Bee Master Template iPart. We're going to select him, her, and then place it into this assembly. So then you get this prompt. Inventor's going, Reet, you're going to place your iPart. You said you wanted a custom parameter, so here you go. There's the length. Type in what you want the length to be. So we can type in 441 millimeters. That's what this length needs to be cut to house the PCB board that we're going to be using. Then you left click inside the graphics window, and then it'll cut the board down to 441 mil length. And you're probably thinking, well, has it though? Has it though? Can we be sure about that it has actually done that? Well, let's just have a check, right? Let's double click the part, and let's go to tools and measure distance, and let's measure distance from here to here. Go on, you can get it. There you go. 441 mil length. Absolutely bob on the money. And then click return. So there's the first variant of the iPart. That's the first derivative created. And what Inventor's done, if we click place again, it's created that derivative in the same folder as the Queen Bee iPart, and that is the 441 mil length iPart. Now you could probably somehow maybe find a way of mapping the length into the file name, but that's when I kind of gave up. It's very difficult to do that. So I haven't figured that bit out yet, but it's not really that important, I don't think. Anyway. Right, so we're going to place a second variant, and so we're going to select the plastic board, and then this variant is going to be maybe 865 mil. That's going to be the second one. We're going to place him there. Click OK, and then click dismiss. There you go. There's the 800 and forgot the number millimeters value board placed into the assembly there. Click place. We've got a second variant. See what it's doing? It's adding 0, then 0, 1, then it'll add 0, 2, 0, 3, 0, 4. So as you use this iPart, you're never going to get spammy, horrible duplicate file names which mean nothing. They actually do mean something. You've got the part number and then just an incremental number next to it, so you know that all of these parts are TFI-12345. You know what the part number is. So for the final part, let's just place 3. We'll call this one 500 mil, bang on. And then place that in there. Click OK. Click dismiss, and there's the 500 mil board placed in. Right, let's click save, and we're going to save this assembly as just, I don't know, boards, something like that. and then click OK. And now we need to create parts list. So how do we do that? How do we create a parts list and then quantify all of this as one length? Because we don't want to buy or itemize 3 different boards with 3 different lengths. We want to combine them all together. Well, because of the prep work that we've done, that is going to happen automatically. So we're going to create a drawing, and then we're going to create a base view of the assembly that we've just made, right? So boards.iam, that's the one I've just saved. Drop a view in. There he is. And then we're going to click annotate at the top, create a parts list of this assembly, so we're picking up that view. And then for the BOM view, I'm going to go for parts only because that's all we've got. And then click OK. It's going to say we need to enable the BOM view. That's fine. Click OK on that. And then we drop the parts list in, and there you go. There's the quantity. It knows to quantify all of these parts together. It knows to combine them all based on the part number. They've all got the same part number, and then it quantifies them all based on the length. So those 3 boards equals a total of 1806 millimeters, which is obviously 1.806 meters in length. Now, the next thing you can do, if you want to, is you can round this number down, which is wrong. You'd always want to round it up. But Inventor's not that clever. You can't round it up, unfortunately. Well, not that I know of anyway, in the short time that I've been messing about with it. But if you double-click your parts list, right, so move your mouse over the parts list till it goes red, double-click it, right-click on the column header, and then go to Format the Column. And then in this Apply Units Formatting, on the Column Format tab, you can click that there, and then you can change the precision and the units to be whatever you want. So you can say, right, well, instead of millimeters, because we're into the range of meters now, we can say show it the value in meters, show the length in meters, change the separator to a dot, and then for precision you can say 1 decimal place, for example, and then click OK. And as you can see, it was 1806 millimeters, but it's rounded it down to 1.8 meters, which is obviously wrong, because if we bought in 1.8 meters, there wouldn't be enough, would be 6 mil short, which isn't the end of the world. But if that was 1830 millimeters, it would still round it down. So you do need to be a little bit careful with that. It should round it up, but it just doesn't have the intelligence to do that. Autodesk, if you're watching, that's a thing. That should be really, there should be an option there for which way it rounds it up or down. But it's, as long as you know it, if you know that it's rounding it to the wrong value, you can change the decimal place, and you can just say, well, you know what, now that's 1.81, so that's actually rounded it up, because it's obviously above 5. But even if it's below 5, it should still round it up, because we're talking about cut lengths here. So that's a thing. I'm not going to labour that point anymore. That, you know, I'm sure you know what I mean. And you click apply, and there you go. There's your quantity, and then you can balloon it up if you want to. Auto balloon that view, balloon up all these parts. Select the placement. You can have the balloon per part if you want to, that kind of thing. So item 1 is TFI 12345, and we need 1.81 meters of it. There you go. That's the thing. So I think the next logical question from this would be, well, okay, we need 1.81, but we buy it in 2 meter lengths. Can we round it up to be 2 meters? Well, not in Inventor. In your PDM system, probably. But in Inventor, it's just going to show you the real lengths of it. So I don't think you can round it up like that to what you would buy it in. Inventor's not really designed to do that kind of calculation. So that is what it is. All right, so that's it. That's pretty much it. I don't think there's anything else I need to cover on this topic. You've got your Queen Bee iPart. You've got your derivatives, which are 0, 0, 1, 0, 2. And it's going to continue to spit those out. Oh, one thing I need to just mention, because we did do it. The description. So because we give a constant description to Queen Bee, the description of every one of these parts that we create will always be plastic PCB carrier board, because you want that to be the same. If it wasn't the same, if it had the cut length in the description of each part, what you'll end up with is like a varies bit of text in there, because it does. The description varies across each one of the parts. So that's not happening, which is good. So if we go to value derivative number 1, open that up. So this is the one which is cut to 800 and something length. Let's go to the eye properties of that part, and what you should see on the project tab is cut to a length of 865 mil. So it's detected the length parameter as per the Queen Bee eye part value. You know, the chevrons cut to a length of open chevrons, length, closed chevrons. So it's picked up that parameter and it's put it in there. So each part should have a link to what its actual size is. So that's a good thing. That's worked. And that's all I need to show, I think. That's how you create a custom cut length iPart that you can use over and over again. This is actually a real world example, like I said at the start of the video. Did this for a customer about 10 years ago. Had to figure it out myself. That was well before the days of YouTube even existed. So It's one of those ones I've been meaning to show on the channel for a long time, but I just couldn't really figure out whether it was still relevant, whether things had changed, but actually not really much has changed in the 10 years since I first did this, so that's a good thing. Anyway, hope that was useful. If it was, please press like on the video, and all that sort of stuff, you know the deals, share it around, comment, subscribe if you haven't done already, and cheery bye!